Designing a RESTful web service. Designing a RESTful web service is not different from designing traditional web applications. We still have business requirements. We still have users who want to do things with data. And we still have hardware constraints and software architectures to deal with. The main difference, however, is that we look at the requirements to tease out resources and forgot about specific actions to be taken on these resources. We can think of RESTful web service design as being similar to object-oriented design. In OOD, we try to identify objects from the data we wanted to represent together with actions that an object can have. But the similarities end at the data structure definition. Because with RESTful web services, we already have specific calls that are part of the protocol itself. The underlying RESTful web service design principles can be summarized in the following 4 steps. Number 1. Requirements gathering. This step is similar to traditional software requirement gathering practices. Number 2. Resource identification. This step is similar to OOD, where we identify objects but we don't worry about messaging between objects. Number 3. Resources representation definition. Because we exchange representation between clients and servers, we should define what kind of representation we need to use. Typically, we use XML, but JSON has gained popularity. That's not to say that we can't use any other form of resource representation. On the contrary, we could use XHTML or any other form of binary representation, though we let the requirements guide our choices. Principles of REST web service design. The key to creating web services in a REST network is to identify all of the conceptual entities that you wish to expose as services. Above we saw some examples of resources: parts list, detailed part data, purchase order. Create a URL to each resource. The resources should be nouns, not verbs. For example, do not use this: http www.partsdepot.com parts get part id not 345. Note the verb get part, instead use a noun. http www.partsdepot.com parts not 345. Categorize your resources according to whether clients can just receive a representation of resource or whether clients can modify the resource. For the former, make those resources accessible using an HTTP GET. For the latter, make those resources accessible using HTTP POST, PUT, and or delete. All resources accessible via HTTP GET should be side effect free. That is, the resource should just return a representation of the resource. Invoking the resource should not result in modifying the resource. No man, woman is an island. Likewise, no representation should be an island. In other words, put hyperlinks within resource representations to enable clients to drill down for more information and or to obtain related information. Design to reveal data gradually. Don't reveal everything in a single response document. Provide hyperlinks to obtain more details. Specify the format of response data using a schema: DTD, W3C schema, RelaxNG, or Sematron. For those services that require a POST or PUT to it, also provide a schema to specify format of response. Describe how your services are to be invoked using either WSDL document or simply an HTML document. Creating the REST web service. Creating the customer entity. To start, create a simple customer class with ID, name and address fields. This class represents the customer entity we will be managing with our web service. Use the file, new, class wizard, put customer in the name field, in the package field and finish the wizard. Replace the contents of the generated class with the following code. This is the code. Creating the customer resource class, the core of our web service. Select the REST demo project and invoke the new web service wizard from the toolbar. That is, you can see in this picture. Make sure the project combo displays the REST demo project and REST framework is selected. Select the create new Java bean and click next. All the things you can see in these pictures. 2. Fill out the page as shown in the following screenshot. The URL path field indicates the path at which this resource can be reached. For this tutorial, we will use customers as this resource manages our customer list. The resource will thus be hosted at customers. Singleton lifecycle ensures that only one instance of this class will be created by Jersey per web application. The consumes and produces combos can be used to specify the default MIME types of data which this resource can accept and generate. These values can be overridden by individual methods in the class. As mentioned above, we will be serializing to XML, so we use the application XML MIME type. Number 3. Click the Add button in the above dialog to add the method that will fetch a list of customers. Fill out the wizard that pops up like so and click Finish. The HTTP method combo can be used to specify what type of HTTP request this method will respond to. In this case, we wish to respond an HTTP GET request. The method signature preview will be updated as you make changes to the page, giving you an idea of what your method will look like once generated. Number 4. Click the Add button again to add a method that will return details of a specific customer. The URL path field specifies the path at which this method can be reached relative to the containing resource. In this case, we specify ID, which means this resource method can be reached at customer's ID. The curly braces denote a URI variable. These variables are substituted at runtime in order for a resource to respond to a request based on the substituted URI. Click Add to add the method parameter, which can be directly edited in this table. Since we need the value of the ID variable, we use the path param annotation to map it to the CID parameter. Finally, add a method which also allows us to add a new customer to our list.